Have you heard the wild idea that our universe might actually be on the inside of a black hole? It sounds like cosmic fan fiction, but it's a serious hypothesis called black hole cosmology. Originally proposed in the 1970s, it's recently getting fresh attention thanks to galaxy spin data from the James Webb Telescope. We'll unpack why this idea isn't just science fiction, from how Einstein's equations allow it to the role of rotation and what this means for a Big Bang. Spoiler, reality might be weirder than fiction. Black hole cosmology suggests that our observable universe is inside the event horizon of a giant black hole in a larger, parent universe. Instead of a singular point called the Big Bang, imagine a gravitational collapse in another universe. No singularity, just matter collapsing inside the event horizon and then bouncing outward into expansion that looks like our Big Bang. Recent data showing that most observed galaxies rotate the same way hints at a large rotation inherited from a spinning parent black hole, a cosmic fingerprint from before our universe began. Einstein's field equations describe how matter and energy shape space-time. For our scenario, an exact solution inside what we call the Kerr metric describes a rotating black hole. A Kerr black hole has two key features, an event horizon and an outer region called the ergosphere, where space-time is dragged around so violently that everything, even light, must participate in the rotation. Now imagine the black hole interior as a universe. This bounce happens inside a rotating space-time. If torsion or quantum gravity avoids a singularity, the inside could expand, inheriting the parent's spin. That expansion becomes what we think is our Big Bang, launching a universe with an axis already built in by the Kerr geometry. So Einstein's equations don't just allow static black holes. They also could describe rotating ones whose interiors could nurture whole universes. In 2024, data from the James Webb Space Telescope shocked astronomers. JWST looked deep into space and back in time and found that early galaxies already had significant spin. Not only that, but researchers noticed that most galaxies we see today tend to spin in the same direction across vast cosmic regions. Now that's strange. In standard cosmology, the universe should be pretty symmetrical and large scale. No cosmic right-handedness or left-handedness. In cosmology, this is called perisymmetry. But this unexpected spin alignment could hint at an origin involving some sort of rotation, not from within the universe, but inherited from something bigger outside of it. A rotating black hole, like the one described in Einstein's Kerr solution, would naturally pass on angular momentum to anything inside of it. If our universe is inside such a black hole, then the spin alignment we observe today might just be the echo of our cosmic parent's rotation. In traditional cosmology, like I said, the Big Bang starts with a singularity, infinite density, zero volume, and no time before it. But here's the problem. Singularities aren't exactly physics. They're kind of what you get when your math breaks and your theory runs out of steam. You don't really know what to do. That's where bounce cosmology steps in. In these models, instead of a singular beginning, the universe contracts down from a previous state, sometimes from within a black hole, and then bounces into expansion. No infinity, no breakdown, just an extreme but finite state followed by rapid expansion. Some versions, like the Einstein-Cartan theory, suggest that spin, which is called torsion in this context, builds up and pushes back, halting collapse before a singularity forms. Others invoke some sort of quantum gravity effects. Either way, the bounce replaces the singularity and gives us a natural transition into the hot, dense state of the early universe without invoking any sort of singularity magic. And if that black hole is spinning, that bounce happens inside a rotating structure. And maybe that could even set up the universe to have a preferred direction. Now, what are some implications and open questions that come with this? I mean, if our universe is inside a black hole, the horizon isn't cosmic doom, but rather our universe's boundary. Gravity shapes us from the inside out. It could also explain mysteries like inflation, dark energy, and the Hubble tension, which is differences in measured expansion rates, since inherited spin or bounce conditions tweak early cosmology. But there are some big questions that remain. Do we see remnants of rotation in the cosmic microwave background or galaxy clustering? does bounce cosmology match? Elemental abundances, maybe? And I guess the holy grail would be, can gravitational waves from black holes in another universe leak in? Most physicists remain skeptical, but the idea remains compelling. It essentially forces us to re-examine the Big Bang not as a creation, but as a profound rebirth. So, yeah, it's possible our universe began inside a spinning black hole in another cosmos. Einstein's equations allow it, the galaxy spins hint at it, and bounce models avoid the nightmare of singularities. But it is one theory among many, and it's still speculative. Still, if true, we're pretty much the inside story of somebody else's cosmic collapse. Do you think this theory is possible? Comment below what you think about it, and let me know other theories that you'd like me to explore. Thanks for watching, guys, and keep expanding your universe. See you next time. Don't forget to like and subscribe. It's free, and you can change your mind at any point in time, and it really helps me out as well.